Right, it's time for some algebra, so let us make it maths. Okay, so today we're doing addition and subtraction of fractions, and so let's run through a few examples, right? It seems to be going quite well. Oh, I can get that. Okay, so 1 over 12 plus 5 over 8. Now, hopefully I'm correct in saying you wouldn't just go, oh, we're going to put this over 72, right? That wouldn't be the denominator you'd choose. You'd probably choose the lowest common denominator. So what is your lowest common denominator when you're considering these fractions with denominators of 12 and 8? That was a long-winded. What's your LCD of these two fractions? Okay, so your LCD with a bit of luck, you're like, wait a second. 12 doesn't work. 24, oh, that seems to work. So you looked at this and went, okay, so we want each of these to be 24 because they both of these go into it. So for the 12, we went 2 times 12 to give us the 24. And for the 8, you went, okay, that's 3 times 8. So now they've got the same denominator, so that in the next step you could go, okay, well, if they're both over, what do we say, 24, then we can add them, because that's when we add fractions. Denominator is the same, and so you got some number over 24. So probably thought of this as, well, what you do to the bottom, you do to the top. Okay, that kind of idea, and we're going to interrogate that a bit more. So we had 1 over 12, so we've just multiplied this by 2. Now, just a reference to yesterday's idea of, so that I don't sit here going like this all day long. This is because we're basically going, if we've got this number here, 2 over 2 is just the number 1, so we're going 1 times 1 over 12. But we're just writing 1 in a special way so that the fraction stays the same. So that's where that idea of what you do to the top, you do to the bottom, but there's some good mathematical rigor behind it. Okay, so the same idea here, we're multiplying by 1, so we had 5 over 8, and we're multiplying it by 1. 1 we're just writing as 3 over 3, so that our denominators became 24 and 24, so they're the same. So we've got 2 times 1 is 2, 3 times 5 is 15, give or take. So the whole thing's 17 over 24. Okay, so long-winded approach for fractions that you probably did quite quickly before. Of course, we can get into the algebra, right? Okay, so maybe a little pause, breathe. Cool, so let's use those same concepts, and we're going to draw on them without writing out 100 million steps like this. So here, we want our common denominator to be the lowest number / expression, perhaps, that both of these denominators go into. So we're considering 3x, and we are considering 2y. So what is our LCD in this case? Well, in this case, it's kind of boring because we're just going to multiply them together. There's nothing more we can really do. So we can get 6xy. Now we ask ourselves, okay, well, at the top here, we had x plus 2. So we still got x plus 2. But let's do it in that kind of, what did we multiply by? So what did we multiply 3x by to get 6xy? Well, we multiplied it by 2y. So therefore, we needed to multiply the numerator by 2y because we already saw this idea of multiplying by 1, but in a special way. Okay, cool. Then we've got this one here, and I'm going to circle in or square in, rectangle something in, that minus as well, because we're subtracting our y minus 1. And again, let's stick to this idea of, what do we do to the top to the bottom, right? And so 2y, we had to multiply by, not 2x. What did we have to multiply 2y by to get 6xy? Well, by 3x. And then what we do to the bottom, we do to the top. So we're multiplying the top by 3x. I'm writing at the beginning because this looks a bit more what we're used to. I mean, nothing wrong if you wrote 3x over here, but I don't know, kind of I'm more comfortable and used to, I guess, writing 3x here. Okay, cool. Equals, and we've got 6xy as our denominator. And then from there, I'm sure you're comfortable. You're going to multiply that in, you're going to multiply that in, and then you're going to simplify. So let's do that. So we've got 2xy plus 4y minus 3xy. What's our last term in the numerator? And it's just to check plus 3x. Remember, it's minus times minus. Cool. And then we go along and I don't know what's happened to my colors now, but well, 2xy minus 3xy. I don't know. That gives us minus xy, 4y plus 3x. Doesn't matter what order we write this in for now. Maybe you wanted to put the x's first. Doesn't really matter. Maybe you wanted me to move my head out the way so you could actually see that. Maybe you didn't. Okay, so same thing's going to apply when you've got multiple denominators. We're looking for our LCD. A squared b, ab, a. What's our lowest common denominator, our LCD in this case? Well, we've got a squared, so that's going to have to be a squared, and we've got a b, so it's b. Maybe let's just put that you've got a squared b. Okay, well, 2 over a squared b is 2 over a squared b minus, maybe let's stick to these as well. So our minus 3, this part here, minus 3, well, we had ab, and we still had to multiply that by a. And then we've got our last bit, which is plus 1. So plus 1, and we still needed to multiply that by, well, a still needed to be multiplied by a, b. And, oh, right, not too much more we could do there. Right, there we go. And you could have written plus ab, not plus 1ab. Okay, let's head into our last couple. 3 over x squared minus 1. I mean, what do you think? You may have read it above, and that's fine. And I mean, just draw on what we've been doing most of this section. We've got multiple terms on the denominator here. Multiple terms. So what's it crying out to do? Well, I don't know if it's crying out to do it or to be done to it. I don't know. What it's crying out is for us to factorize. So we're going to factorize this. So actually, we're not quite ready for this. So I'm going to look at this part here and say, well, 3 over x plus 1, x plus 1, x minus 1. And on our other one, we're going to look at this and say minus 2 over, and here we can factorize trinomial, and we've got x squared minus 2x plus 1. This looks like x minus 1 squared. I'm going to write it as x minus 1, just so we can keep track of it nicely for now. But we could write it as the other. Okay, so let's do this and go, okay, so in this case, what is our LCD? I'll be interested to see what you put here, because I reckon x plus 1, x minus 1, x minus 1. So like in this one here, we had a squared. We had to have a squared over here. So here we've got something squared, so we need it squared. Let's keep at this, and then we'll look at, if we wrote it as a squared, how we'd think of it. We've got 3, x plus 1, x minus 1, x plus 1, x minus 1. So we still need to multiply that by x minus 1. Because think, this we still had to multiply by x minus 1, so this we had to multiply by x minus 1. And then we've got our minus 2. And what do we need to multiply this by? Still x plus 1, because if we look at the previous step, we still need to multiply that by x plus 1, therefore multiply that by x plus 1. Okay, and then again, I'll leave it to you to finish this off, multiply and add like terms. Let's just look at it quickly in terms of the squares and say, well, if instead of writing this twice, we wrote it as a squared, let's just check could we still make sense of this. We wrote it as squared. In this case, we wrote x minus 1 squared. Yeah, I mean, x plus 1, x minus 1 squared, x plus 1, x minus 1. You just let it multiply by x minus 1. I think writing that other bracket out really just brings it home to start with. I don't know, what do you think? Okay, so our last example. We've got a whole lot of things going on here. So same strategy, right? Factorize denominators, find your LCD. So give it a go. And once you've given it a go, just write down maybe anything that you notice about this one. Or maybe you don't notice anything. But like, what do you notice? Do you get there and you're like, oh, okay, well, this makes sense. This looks like the others. Or is there something different? I don't know. Give it a go and pop it down. Because maybe we've got 2x minus 2 minus, I'm just looking at the denominators, x plus 2, x minus 2 minus x plus 2. I'm a big fan of putting these into brackets so we can really make sure 1, 2, 1, 2, 1, 2. Okay, and here we've got 1, x minus 1, x. Okay, so now when we do our LCD, I'm just going to put an equals because you must keep going with that one. Okay, so now we look at our LCD and we go, well, our LCD, we need to have a 2, x minus 2, x plus 2, x plus 2 we already got. So now we kind of go through this and go, okay, well, 2x minus 2, well, we still need to multiply this by x plus 2. You don't have to write this bit in, but this pinky bit here. But I'm just doing it to go, x plus 2, so we must multiply the top by x plus 2. In other words, we've got 1 x plus 2. And then we're going to go along and go, minus. Well, x plus 2, x minus 2, so we still need to multiply this by 2, so let's multiply this by 2. 2, x minus 1. And then for our last term in the numerator, we've got this minus x, so minus. We've just got x plus 2, so we still need to multiply it by 2 x minus 2. And we still need to multiply it by x. I'm just sneakily writing it in a neater form, but if you wrote 2x minus 2x, all good. It's kind of nice to put in those neat forms, I think. Okay, and again, equals, ... multiply in, add your like terms on the numerator. So you've got, x minus 2x minus 2x squared. So I was going to say, should I finish this off? And then, of course, you write no. But let me finish it off for sake of completion. So we've got 2x minus 2, x plus 2. Here we've got x minus 2x is minus x. And we're going to have plus 4. No, I'm going to lose track of this, aren't I? X plus 2 minus 2x, especially with all these things in the way here. Yeah. Okay, x minus 2x plus 2 minus 2x squared plus 4x. Hopefully looking good, equals, that denominator stays the same, x plus 2. Got a minus 2x squared. So that's this part. Can be useful. I'm just going to tick that we got those bits off. And go, well, we've got x minus x plus 3x. Plus 3x. That was a squared. And our last bit was 2 plus 2 is plus 4. I don't think we can factorize that nicely, because this is the thing to check. If you factorize this, would it simplify with the denominator? So let's just have a quick look. And as I check with my head in the way, right? I don't know. I don't think that factorizes nicely, but I'll leave it to you to maybe triple check that. Okay, so hopefully that's okay. Exercise 14. As always, enjoy and remember to make it maths. Oh, algebra, right?